Example number 7 in the U substitution. Alright, let's see. Our choice of U. Well, I see not really stuff, but I can think of the entire denominator as stuff. So my entire denominator is stuff. U equals 3x squared minus 5. Go quickly now through my process. Du is 6x dx, and dx equals du over 6x. Put a box. Now I come over. I need to pull out, let's see, I'm going to do the blue step here. So I'm not going to pull out yet. My denominator is u, my numerator is x, and my dx is du over 6x. Cool. So now I'm going to go to white, and my x's cancel out. My step would be to pull out the 1/6, the integral of 1 over u du. Hopefully you have this one committed to memory. The antiderivative of 1 over u du, book of memories, is natural log absolute value of u plus c. So my final answer, 1/6 times the natural log absolute value 3x squared minus 5 plus c. Please try number 8, the integral of 1 over 9 minus 2x dx. Do it now, press pause, and I'm going to reveal the solution without talking about it. You should get this one right. And our answer, -1/2 natural log of absolute value 9 minus 2x plus c. Now 9 is a very important example to see next to example 8, because our u is the same thing, u equals 9 minus 2x, but notice that u is not the entire denominator, u is the stuff inside the denominator. So let's see how that plays out. Du is, again, -2 dx, and dx is du over -2. The reason I show this example, it is so easy that once you do a couple natural logs to abuse the natural log. We don't want to abuse anybody, including the natural log. So I'm going to pull out a -1/2 times the integral of 1 over, not u by itself, but u cubed du. It would be wrong to say natural log of u cubed. It's only natural log when it's 1 over stuff to the power of 1. 1 over x or 1 over u. So this is 1 over u cubed. And it's so easy to do this problem, but it's also easy to abuse the natural log. So what we're going to write is u to the -3 du. So this is just simple reverse power rule. -1/2 u to the -2 over -2 plus c, with answer in terms of x. No natural log, no abuse. And now, example 10. Ooh, this is a fun one because there are so many choices of u. So some people let u equal x squared. Some of these will work and some of these won't. Some people let u equal e to the 3 over x, while other people will say u equals 3 over x alone, just like that. One of these works real nicely. One of these works with a lot of kind of tricky effort, and one of these just won't work altogether. Let's take a look at the one that will not work altogether, the first one. So u equals x squared, du is 2x dx, and of course dx is du over 2x. Let's take a look at why this one will not work. So I'm going to pull out a 1/2. I have e to the 3 over x over u, and then dx is du over 2x. Nope, I'm not getting rid of any x's here. This way will not work. Now let's take a look at the one that works the best, the one in yellow. U equals 3 over x du. You know what the hardest part about these? problems and antiderivatives is regular derivatives. Some people struggle with the derivative of 3 over x. So du would be negative 3 over x squared dx. And then my dx is going to be x squared du, see I'm cross multiplying, over negative 3. This is what is hardest for everybody, it seems. It's just getting to that. Anyway, that works well, and it comes out to be, I'm going to pull out a negative 1/3 times the integral of, this is going to be e to the u, and then my x squared here is going to cancel out with my x squared here, so e to the u du. Nice. Book of memories, negative 1/3. The antiderivative of e to the u is itself e to the u plus c, leaving me with my final answer, negative 1/3 e to the 3 over x plus c. And maybe I haven't emphasized enough, take the derivative of that. Make sure you get the original. Now for fun, let's see this one in pink, how this one would work. Du would be, well, e to the stuff times the derivative of the stuff, which is negative 3 over x squared dx. And you might see that that is actually, we can sub this with u times negative 3 over x squared dx. So then dx becomes x squared du over negative 3u. Wow, what cancels out here? Well, I see that the x squared cancels out with the x squared. This will become u, so this here becomes u, but then I have u in the denominator, so that cancels out to be 1. So I am left with the integral of, pull out a negative 1/3, and I'm left with good old du. And then I have negative 1/3. The antiderivative of du is simply u plus c, which gives me negative 1/3 e to the 3 over x plus c. The same result. But again, I prefer this one right here. Example 11. Please, 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 in a moment, you're going to press pause and try it. It's important to simulate how you might feel on a test. Anyway, press pause now. It's quite possible that after trying several choices of u, you were unsuccessful. The reason is this problem doesn't involve a u substitution. I like to call it, when in a jam, expand. You see, this problem could have been done in the lesson 1. I'm going to expand this. So first I'll FOIL this, if you will, x squared minus 6x plus 9, and then I'll take this x and distribute it in, and I'll get x to the power of 3 minus 6x squared plus 9x dx. And then this is just good old-fashioned reverse power rule, a simple polynomial. X to the power of 4 over 4 minus 6x cubed over 3, so that will be reduced to 2, plus 9x squared over 2 plus c. This is the easiest one we had in the notes so far. When in a jam, expand. We do this u substitution and people forget that not every problem requires the u substitution. Example 12, I feel strongly that you can get example 12. Press pause and work it out. Important to note here that there is no absolute value. I let u equal natural log of x, found my dx, and then it was simply u to the 3/2 times 2/3 without any absolute value. Example 13 looks nice and easy, the integral of tangent of x dx, and the number one mistake that people make here is thinking, I know the answer to this. I have a book of memories, and they call the answer secant squared of x plus c. That would be wrong. The derivative of tangent is secant squared of x, and not the antiderivative of tangent of x. This problem will involve a u substitution, but right now we don't really have choices of u. So with a little bit of thought, you might think to write the tangent of x as sine of x over the cosine of x dx. Now we have two choices of u. First choice would be sine of x, second choice cosine x. Try them both. But after you get started just slightly, I think you will see which one is the right choice. One choice is wrong, one choice is right. The wrong choice. U equals the sine of x. Du is the cosine of x dx. Dx equals du over cosine x. If I did that, then I would have the integral of u over, I have cosine of x, but it feels like it cancels out, but it doesn't, because dx is du over cosine x, and they don't cancel. In fact, they combine to be cosine squared x, making it only more difficult. I haven't got rid of the x's. Bad choice. But if I let u equal the cosine of x, it's a different story. I do have to pull out a -1, and the sine x's will cancel out, so I have 1 over u du, and since it's just 1 over u variable by itself, it is going to be the natural log absolute value of u plus c, so negative natural log absolute value of the cosine of x plus c. Example number 14. Just in case you can't read it, the integrand is 5 cosine of e to the 2x dx. Please try to work this one out, pressing pause now. This is a trick. I don't know if any of you saw it, felt it, but do you see this thing out in front? This says, take the derivative of the antiderivative. It's like asking an only child who's a boy, saying, child, let's call him Scott. Scott, who is your father's son? To which Scott replies, why, that's me, because the derivative of the antiderivative is just itself. No work is required here. So the answer is 5 cosine e to the 2x. You might also notice that there is no plus c here, because the last operation that was performed was the derivative. The antiderivative would have produced a c, and then the derivative of that c would be 0. So this and this alone is the answer. Be ready for that on the test, because I'm going to put one, and you will see, I will see, a whole bunch of people writing answers, scratch, and erasing it 100 times, and maybe even putting a hole in the paper, just for the student to realize, hopefully before the time has expired, that oops, I need to read the directions carefully. I need to look out for the derivative out front. LOL. Number 15. All right. This one, I'm going to say, behooves you to commit to memory. In fact, any one of these in the notes, if you commit them to memory, you don't have to show any work. And here's one that I can almost guarantee you're going to see several times. So commit this one to memory. The answer to this is the natural log of absolute value of secant of x plus tangent of x plus c. Commit this to memory. I had a student one time who said, I've got a way to memorize this. LN, he said, Jeremy Lin, basketball player, once played for the Knicks. Jeremy Lin's abs, see the absolute value, Jeremy Lin's abs are sexy and tan. He actually said, Jeremy Lin's abs have a sexy tan, but I like to use the word and, so that we know we have the plus. Jeremy Lin's abs are sexy and tan. So how would this one work out? Well, the secant of x with a little bit of trickery. The secant of x is equal to, I'm going to multiply top and bottom of a fraction here, secant of x over 1, by the secant of x plus tangent of x. One in disguise, secant of x plus tangent of x. When I distribute that, I get secant squared of x plus secant x tan x in the numerator, and then the denominator is simply secant of x plus tan x. Now, I need to do a U substitution here, and this is the final result that I want to get, so it makes sense maybe to let U equal the entire denominator, secant of x plus tangent of x. And here's where it's really cool. Du is going to be this derivative, so that's going to be secant x tan x plus secant squared x. And behold, this entire denominator would cancel out with this numerator here, and then this integral of the secant of x dx equals the integral of 1 over u du, which is natural log absolute value of u plus c, which equals natural log absolute value secant of x plus tangent of x plus c. Jerry Milton's abs are sexy and tan.